Hello guys, welcome back. Um, Today we will discuss identification layer. We came all the way down from infrastructure layer to application layer now. So the application layer is actually the interface of the user with the end device. Uh, for example, your end device is your mobile or your computer. When we just uh, repeated the whole process in a short way. That edge layer contains sensor layers. From sensor layers, data comes and collected at gateway. And from gateway, the data is transferred to cloud where we are accumulating data, we are gathering the data and becoming the huge amount of data. And then we will do some machine learning to predict some feature or classification. And when the data is on the cloud, you can access that data through your mobile phone or from your computer, from where you can see the live data and you can see, you can even interact with your system. So, this is the application there that is providing you an interface to visualize your data, to view your data, or to interact with the data and see the status of different things. And this layer is implemented through a dedicated applications at the end device. Like for a computer application, we use web browser, and there are some protocols: HTTPS, HTTP, SMTP for mail transfer protocol, FTP for file transfer protocol. The same way, there are application layer protocols specified in context of IoT. This layer is responsible for data formatting and representation, how to present it. The application layer in the internet is typically based on HTTP protocol. You guys know that. However, HTTP is not suitable in resource constrained environment like we have in IoT. And, and the HTTP is extremely heavyweight. So their application layer protocol is different, and uh, we'll see, we'll go through, and we'll see those protocols in today's lecture. And what are the reasons that why we it's not good enough those internet protocols we are used to with those. So the reason is that number one, it cannot accommodate the major power constraints of some IoT devices. The connection may not always be stable, may be limited in memory. And finally, not all IoT applications require guaranteed data delivery, data protection, or message acknowledgement. Like we can see in HTTP, HTTP is more secure, and it guarantees data to receive at destination. But sometimes we don't need them in IoT application. So why we use those heavyweight application protocols? These capabilities may be beneficial, but the data overhead and power cost may not be worth it. So uh, the researchers switched to some other lightweight internet protocol. And some of the IoT application layer protocols are listed here, but we'll go through with the bold one because this is part of your syllabus: MQTT, FOAP, RESTful HTTP, and MQTT SM. Now, what is MQTT? So MQTT is actually messaging telemetry transport protocol, and it is simple messaging protocol and light bandwidth. It allows you to send commands to control outputs, read and publish data from the sensor data. It makes it really easy to establish a communication between multiple devices. The basic concepts involved in this MQTT protocol is the publish, subscribe, and the second is messages, and third is topic, and fourth is broker. So basically, there are two ends. One end will publish, and the other end will be subscribed. So the publish, the analogy with the data communication or telecommunication or in any communication, the publish means the one that is transmitting data, and subscribe one is that is receiving the data, and messages is actually the data to which subscriber is interested, and topics. So now we have another thing that is called topic. So there would be different topics. So for any publisher who want to publish some data or send some data, the publisher uh, must select one of the topics. And similarly, the subscriber, if the subscriber is interested in some sort of some particular messages, this subscriber must be subscribed to that particular topic so that it can receive those messages that relate to those topics. And the broker is, you can say, is the bridge between publisher and subscriber. Publisher and subscriber will not directly interconnect with each other, will not directly communicating with each other. There is a broker that that manage the communication between publisher and subscriber. So in simple situation, publisher will send the message while registering with the topic and send it to broker. And any subscriber, if wants to get that message, that subscriber must register to the topics, and then the broker will send those messages to all the subscriber uh, which are registered to those topics. So it's pretty simple concept. And the messages I told you, the data, this could be a command or a data, and the topics are the way you register interest for incoming messages. Okay, so broker MQTT has been specially designed for sensor network and wireless sensor network. MQTT allows devices to send or publish data information on a given topic to a server. So there is an MQTT broker in between publisher and subscriber. The broker then transfers the information to the clients. Sensors are interfaced with the broker, and the other devices that subscribe for and request sensor data are called clients. The sensors themselves are referred to as publisher in the network. A client can be this could be a laptop, a smartphone, tablet, or other mobile devices. The client devices need to subscribe with the broker, as I told you earlier. For receiving data, the subscribed client devices have to establish connection with the broker and request the data. The broker takes the data from the publisher and sends it to the client requesting for it. So if the connection, this is the benefit the of the broker. Why we put the broker there? So this is one of the advantage of the broker. So let's suppose a client made a request for a specific message that is registered to a specific topic, but the connection is the is disconnected after making that request. So the broker will save that data and they will send that back to the client once it reconnect with the broker. And similarly, on the publisher side, the connection between the publisher and the broker is broken after the request has been made. The, the broker forwards appropriate instructions sent by the publisher. So the client device can reconnect and receive requesting data. So here you can see publish subscriber schematic diagram where the topic is temperature and clients are subscribed to that topic via broker and publisher could be I told you it could be a sensor that is connected with some microcontroller and it sends the data to broker and to broker while registering to the temperature topic. So as broker receives the data of the temperature, it will send the data to all clients that are registered to that topic. So the communication using this MQTT protocol consists of four things as MQTT is using TCP protocol. So there is a um handshaking culture for establishing connections and then disconnectivity, establishing connection and transferring data and then disconnectivity. So there are four parts, basic parts. Uh, we can divide the MQTT session into four parts. Number one is connection. So in this stage, the client initiates a TCP/IP connection with the broker using some standard port. So 1883 port will be used for non-encrypted and and 80, 88, 83 uh, port number will be used for encrypted connection through secure socket layer or transport layer security TLS. Authentication is required. Server sends server certificate itself by the client. It could be user ID or password, and client may also send a certificate to the server to authenticate itself. And termination. So if publisher or client, anyone want to terminate the connection, they will send a command or a message disconnect. So disconnect message is a command that will send to terminate the connection. And after that, the TCP connection will be closed. So the publish and subscribe uh, process has a few important tasks in MQTT environment. So the um, the data, the footprint, the code footprints that will be sent during communication consists of 2 byte long header, an optional variable length header, sensor data that we call payload, and the payload would be up to 250 megabits per second in size, and for an important one is the quality of service level indication. So the code footprint also contains that what sort of quality of service level it needs for communication. The one is quality service level 0, that's unacknowledged service. Quality QoS level 1 means acknowledged service, and quality of service level 2 is assured service. So as the quality of service exceeding, uh, it, it will be more secure, but facing it will need more bandwidth and it will face latency issues as well. Another thing is that Four types of operation that can be performed by a client: publish, uh, to send some data, to broker uh, on a specific topic, and subscribe. The client can subscribe for specific topics in the network, like mobile device might subscribe with a broker to read current temperature. And there is another one, a part of subscribe and publish: unsubscribe. The client may later unsubscribe to certain topic, and the ping service is used to make sure that the connection is still live. So these are few services carried out in this communication pattern. So quality service level 0 is the simplest one. It doesn't need any acknowledgement, and it is just like it will send data and, and fire and forget type communication, quality service level. And this service level should be used if you have reliable connectivity. Means you are sure that if I send the data, it will definitely receive on the other end. So why then you need acknowledgement if you have a reliable internet network? Message loss on a small scale doesn't matter. Message need to be delivered fast. So this quality of service level is required if you have these three in your mind. Quality level service one, it needs an acknowledgement. So whenever publisher sends data to broker, the broker should send a message about the acknowledgement. So the acknowledgement could be publisher back. This is an acknowledgement message. So whenever publisher sends the data, the broker will send that message. It means that it is received. If it is not received for a certain period of time, uh, if the time window, the specific time window passed, then the publisher will send a duplication, another packet, a copy of that message, but with a flag, with dup flag, dup flag, so that the publisher should know that this is a duplication, and the publisher sends the data, but the data was not received. So this is the copy of the lost data. So in that scenario, the publisher will keep copy of each uh, submitted packets, and when it receives the acknowledgement, then that packet will be removed from publisher site. And the same pattern of communication will also be carried out in between broker and subscriber. The broker will send the packet to subscriber that is registered to a specific topic. Then subscriber will send back a published back acknowledgement. And if if in some case it failed to submit that published back message for a certain period of time, the broker will resend that frame, that data, but with dupe flag will be turned on. The next is so before going to next, I would like to say that the quality of service level one is implemented in uh, some uh, well-known web servers like Amazon and Azure, AWS, IoT, Amazon Web Server, and Azure. So they are using the quality service level one. In quality service level two, it is very expensive in terms of time and processing, and it is not recommended actually. So if you want a guaranteed transmission of data, then you can use this quality service level 2. How it works: the publisher send the message to broker. Upon receiving that message, the broker will send pub receive PUBREC message, and then the broker will send another message pub release, and when it send that, and upon receiving this message, the broker will send a published uh, completion message. So for one message, there are three messages we need to exchange for guaranteed uh, receiving of a single packet. On the broker and subscriber side, brokers will send the publisher message to subscriber, and the subscriber, when receive that message, it will send publish received message, and after that the broker will send publish release message, and against this the subscriber will send a message of a publication completion message. If any of the packet uh, any of the message is failed to reach to the destination, the sender will send a copy of the message with the dupe flag will turn on. So as it is obvious that quality of service level 2 is much slower than level 1 or 0 because of the number of steps involved. This service level should be used if message can be delivered slowly. Message duplication causes issues. Most commercial brokers like AWS, IoT, Azure, IoT do not support quality of service level 2 as on today's date. So why MQTT is beneficial for us? It is beneficial because it provides independent operation uh, due to MQTT. The nodes function independently from one another without any knowledge of each other. They don't know the subscriber or the publisher. The broker is in between. And another one is time and synchronization independence. So the subscriber doesn't need to make sure that the publisher doesn't need to make sure that the subscriber is live, and it is when it sends the data, and the subscriber will receive at that moment. There may be situation that if subscriber is not connected, but publisher uh, will not care about that. It will just sending the data to broker, and broker will pool those data, and upon connectivity of subscriber, the broker will send save data to subscriber. So for this mode of operation, time and synchronization independence, we have this facility. Security flexibility. So as TCP is a secure transfer control protocol, so and the MQTT is using TCP, so it is secure but a bit slow, uh, and there is a huge overhead as well. So the researcher converged to that not to encrypt all the packet, but only they encrypt the payload. And when you do some encryption, that will add extra data that will add increase in the frame size and extra overhead. So rather than encrypting the whole frame, they only encrypt the payload to decrease the to minimize the drawbacks that because of the TCP protocol. Another benefit is that there are varied levels of guaranteed delivery, quality service level 0, 1, and 2. I have explained that to you. This is another benefit, and it's a bit different. Lost will and testament (LWT). What is this? This is actually a message. Uh, the publisher will write that message, will store that message, and that message will be sent to the broker just in case. So this message will be transferred to subscriber only when the connectivity of publisher uh, is down. So this message will serve or informed is a form of information to the subscriber that the publisher is not live and disconnected. So there are these were the benefits, but there are some drawbacks as well. Need for central broker. For this type of communication, we need a central broker, and and all the communication depends on the central broker. So the broker should be scalable. Means how many publisher and subscriber the broker uh, can have and do the work smoothly. So it should be a scalable. And another one is open to integration. So a variety of publisher and subscribers should integrate with the broker. And another important thing is the failure resistance. So if the broker is failed, all the communication on the system will be fall to the ground. So the broker should be failure resistance. It should not be vulnerable to different types of failure that can end it to the failure of the system. So as we said that MQTT using TCP protocol, it is secure, but it has additional overhead. So recently a new version of MQTT is designed that is known as MQTT sensor network that is based on UDP user datagram protocol. So you guys know that UDP we lost the security, but we UDP is more efficient. So it is specifically constrained application protocol (CoAP), specifically designed for constrained hardware. So the hardware that doesn't support HTTP or TCP/IP can use CoAP protocol. So designer of this protocol actually inspired by HTTP and designed the CoAP protocol using UDP and IP protocol. It is a lightweight protocol that needs low power IoT applications like for communication between battery powered IoT devices. So likewise, HTTP, it also follows client server model that can use get, put, delete, or post informational resource over the network. So CoAP is an application protocol for IoT. It's one other application protocol. CoAP make uses of two types, request and response. In CoAP, request and response on the type of messages and they have these are the lightweight messages. The message contains base header followed by a message body, and messages or data packets are small in size so that they can communicate among constrained devices without data loss. The message can be confirmable or non-confirmable. Confirmable messages are those that need acknowledgement, and non-confirmable messages are those that doesn't need acknowledgement. QoAP is not a replacement for HTTP, but it's a new design. And QoAP implies two-layer structure. The two-layer structures are message layer and request response layer. Message layer supports four types of messages: confirmation, non-confirmable, acknowledgement, and reset. Message layer is meant for retransmission lost packets. Request response layer contains methods like get, put, post, and delete. So, wireless protocol mainly fall under three layers. IoT uses TCP, UDP protocols. UDP is less complex uh, as compared to TCP. UDP is a good choice, but the problem is that it is not stable. And to care of that, it needs to be combined with application layer. So HTTP has computational complexity, low data rate, and high energy consumption. Therefore, it is not suitable for constrained devices. And IETF came with numerous protocols, and QoAP is one of them. So the TCP, how does the TCP do the handshake? We can see that. So there are two objects that want to communicate, user A and user B. The first will sync to user B, and the user B will sync back and to sync acknowledgement, and then the user A will acknowledge that your acknowledgement has been received, and after that, then the connection is established, and the communication will start. Application layer has those protocols that you can see in the table: HTTP, QoAP, AB, HTTP, SNMP, IPFix. So, guys, today's lecture was about application layer, and we have studied in application layer constrained application protocol QoAP. So, we'll see you soon. So, take care of yourself. Bye.